Hi guys, welcome to Weather Lessons. I am meteorologist Alexandra Cranford coming to you not from our WWL studio, but from my house because I'm on self-quarantine. So I want to say a huge hello and welcome to everyone out there. If you're an adult stuck at home, if you're a parent looking for something for your kids to do, or particularly if you are a student, welcome. I know that it might be a little weird not going to school right now, but that doesn't mean that we can't talk about cool weather things. So I, again, am stuck at home because of self-quarantining. I was traveling last week and got back in this weekend, so can't show up in the studio. But we are hoping that I will get back soon to the studio and be able to start doing weathercasts. In the meantime, though, we're going to have a lot of fun today talking about some cool weather things. So if you are a student, if you can and if you have access to your keyboard, feel free to let me know where you're watching from. Whether you're from the New Orleans area, from somewhere else, from the North Shore, if you're from, like I am, Slidell, just let me know. I'd love to see where you guys are tuning in from. What we're going to do, and by the way, you'll be able to ask me a few questions and things like that. What we're going to do today is talk about one of my very favorite things. When we talk about weather, we have good weather, we have bad weather, right? And a lot of our jobs as meteorologists is to talk about bad weather and let people know when there's storms and things like that coming. But there is so much beautiful, good weather, right? So I said for my first weather lessons video, I want to talk about cool weather and good weather. Metairie, hello, Des Almonds, hi. Thank you guys for joining. I'm starting to see your comments pop up. So this is my rough outline of what we're going to talk about today. And today's lesson will be pretty quick. We're just going to kind of get into it and then get out after looking at some beautiful photos. But tomorrow we're going to do an experiment. So I will tell you the details of that in just a second. Okay, first of all, what we're talking about today, notice the first line on this list, corona. Interestingly, there is something in the atmosphere called a corona, and there is, of course, also what we've been talking about, almost nonstop on the news and so forth, and in our lives, coronavirus. So they are not associated besides the word corona, which, interestingly, is a Latin word that means crown or wreath. And so both the virus and these beautiful things that I'm about to talk about with weather actually do have that shape. So that's the only thing really that they have to do with each other. Let me show you a quick picture of one of these beautiful coronas. So this is what a weather corona would be. Can you see it? Oh, is the list backwards for the audience? Okay, sorry about that. I'll try to write backwards next time. We'll see if it works. But in any case, this is a corona. And by the way, I want to say thank you to the author of this book. This is Kaleidoscope Sky by Tim Hurd with some beautiful photos that I'll be showing you. So pretty cool. This is the moon, and this is a lunar corona that is showing this nice circle or kind of a concentric circles around the moon. And so this is something interesting that happens when the light, either from the moon or also there are solar coronas as well, when the light shines through water droplets, either of clouds or mist or fog, and it diffracts. So for all my student friends out there who are learning about this or who haven't learned yet, diffraction is essentially spreading out. So the light comes in, it goes through raindrops or little drops of water and so forth, and it spreads out and creates this beautiful kind of hazy halo ring sort of effect. If you can see that somewhat clearly, hopefully a little bit. So that is what a corona is. Interestingly, not only water droplets create this effect, but sometimes even pollen. Who is suffering from pollen allergies right now? Anybody? I'm betting a lot of you are. I know for sure some pollen sufferers who have been sneezing and having different issues. I wanted to show you one picture here of, this is kind of crazy, but it is a pollen corona. So it is these tiny grains of pollen, in this case from a photo taken in Finland. And the light from the moon is shining around these little grains, and is creating this circular effect. So it's doing the same thing. It is diffracting or making the light spread out, even just from pollen. So pretty cool stuff that can happen with that. And by the way, this is another book that I use that I love, Weather by Storm Dunlap. Beautiful photos in this book and great explanations in both of these books as well. Something really quick to remember, which we'll talk about in just a second, is that the smaller the droplet with these coronas, the bigger the diffraction. So the smaller that it gets, the bigger the halo, or the bigger the corona or the circle around the sun or moon. So sometimes you can look up into the sky and you'll see, especially the moon, it's easy I think to see the moon with this sometimes. You'll see a little circle around it. So what does that mean? That would mean that there are bigger droplets that the light is shining through. And sometimes you look up at the moon and I have noticed just massive circles around it before. The angle is huge. And so when that happens, what would that mean? That would mean that the little droplets are very tiny, that the light from the moon is shining through. Okay, related to coronas. Okay, I know this is backwards. We'll work on this. The second one is a halo, so we'll talk about that really quickly. There are these beautiful things called halos. Hey, I'm seeing all you guys. Tell me, by the way, it's popping up. Hi from Destrehan. I'm seeing all your different places. Hey guys. So again, as we get into our first weather lesson, if you're just joining us, this would be a photo of a halo. Do you see the circle around the sun? That would be a halo. So this is something a little bit specific. So this would be from droplets that are actually frozen. So these are really, really high up clouds, cirrus clouds. You may have learned that in school, possibly. They're very high up in the atmosphere where it gets very cold. So in this case, the droplets are frozen. It's ice crystals. So when the sunlight or moonlight shines through these, it doesn't so much spread out into a big haze. It doesn't diffract as much as it just gets bent. So the light gets bent at a certain angle and it creates one of these beautiful halos. The bending, by the way, is called refraction. We've talked about diffraction and now we're talking about refraction. So you can see that the halo is there. What do you think that these two little spots are? Can you see that on either side? This is something that we can definitely see in South Louisiana at times when we have the right conditions. But this is one of my favorite things to see. And actually, if you see me on TV doing my weathercast, you've probably heard me babbling about these things before. They're called sundogs. And when I say that in my school talks, when I go to visit different students at school, the kids are always like, huh? Sundogs? And yeah, they're called sundogs. And I have heard it's because these two special little spots of light follow the sun around like a dog follows its master. So in any case, it can also be called perihelia. That would be the more technical term for it. And it can also be called a mock sun, like not a real sun, but a mock sun. So this happens because of the same effect that we've talked about. The light is coming in, it's hitting the ice crystals in these high cirrus clouds, and it's getting bent. And when it happens, all this happens at just the right angles. You can get these two special spots of light. It is not always as amazingly perfect as this picture is. Sometimes I've seen it where there's only one sundog and then I'm like, what's that weird spot of light in the sky? And then I look around, I'm like, oh, there's the sun. It's on the same horizontal plane. It must be a sundog or a perihelion. So that is one of my favorite things to see, and I tell kids when I go to see these school talks, make sure that you watch out. The next time you kind of see those high cirrus wispy clouds, not every time by any means, but sometimes you can see the beautiful sundog effect. Okay, moving through our little backward list here, and I'll fix this in the future. Rainbows, one of my favorite topics to talk about. Beautiful, beautiful rainbows. So I wanted to show you a quick photo of one, just for those of you, of course, who want to stare at it. We all know what a rainbow is, but I just think they're so gorgeous. For a rainbow to happen, you may know this if you're a student or an adult, but some of you may not have quite gotten here, but for a rainbow to happen, you need the sun and the rain going on at the same time in the sky. So this is definitely something that I look for when I notice that there's a lot of sunlight, and then maybe there's also a shower, which we actually have the ingredients for that a lot, especially in the summer in Louisiana. When that happens, you might get a rainbow. So I do start to look for that. So a rainbow, what you need is the sunshine to your back, and you need the rain to your front. That's how you would see it. So this is a similar thing with light doing cool things with water droplets in the atmosphere, where light comes in, and in this case, it not only gets bent or refracted, but it also gets bounced around or reflected. So in a rainbow, there are two things going on, both of those things at different angles, and that essentially separates the light into this beautiful, these beautiful stripes with red on the outer edge, and then you would have purple on the inside. Something kind of cool is that you may have noticed this. Sometimes you can have double rainbows. I love that. And a lot of times people, when they see these beautiful rainbows, they send us photos or they text it to us at WWLTV. Love seeing that. I try to put them in my weathercast as much as possible. But something kind of cool happens sometimes, which is that you can get a rainbow, and sometimes when there's a double rainbow, even if it's very faint, you get this kind of dark area here. Do you see that? The sky is just a shade or two darker than the rest of the sky. And that's because there is refraction and reflection going on between the two rainbows that kind of creates this shadow effect. And it does have a name, and it's not that dissimilar from my name. It is called Alexander's dark band. So something kind of interesting there. It appears between a primary and a secondary rainbow, or between the two rainbows of a double rainbow. Hey guys, still seeing you guys check in from different points around the area, so nice to see that. Okay, we know about rainbows. Do you guys know about fog bows, or dew bows, or mist bows? These are a little bit rarer, but they do happen, and actually I got a beautiful photo of one of these from one of my sisters in California not long ago, but I wanted to show you this, which kind of gives you the idea, does it? Do you see this very faint rainbow here? Sometimes it's not this faint. Sometimes you can see the rainbow, and it's not so light, but it might actually be like pastel colors. So I don't know if any of you have seen that before, but I haven't seen it actually in person, but it is really pretty. And that happens because of something that we talked about right at the beginning. Do you remember when I said, and all you students, maybe you can recall, the smaller the water droplets, the bigger the diffraction, or the bigger the spreading out effect? Cool, guys. People from Destrehan saying hi, and other areas. Welcome, guys. The smaller the droplet, the bigger the spreading out. And so with a dew bow or a fog bow, or one of these beautiful light colored rainbows that are rare and kind of hard to see, actually, probably hard for many of us to spot. But when you do have this effect, you have very small droplets creating very much diffraction, or a lot of diffraction. The colors that would normally show up in a rainbow, very kind of organized, red, orange, yellow, green, blue, purple, all of those are spreading out so much that they mix, and all the colors either get very faint and pastel, or they become white, and they kind of cancel each other out, and they mix to create this really light effect. So that is something that I, again, have never seen. Got a cool picture of one once or twice, but I've never seen it in real life, I don't think, to my knowledge. So I do really like that, and I would love to see that. You can also get the effect with dew and mist, essentially, very similar to fog. And I did want to show you, I think I have a beautiful photo of another rainbow effect showing up on a spider web. Isn't that gorgeous? I just think that is so beautiful, that iridescent sort of fade from red to purple. I love it so much. And actually, now that I think about it, you know, this kind of has to do with all these unicorn type things, right? Are any of you students watching into unicorn type stuff? Is that still big? I don't know. I don't know if I'm up on the trends enough. But anyway, you can see the pretty rainbow effect going on in a spider web, which I just think is so, so beautiful and cool. And the reason for this is because, of course, on the spider web are little droplets of dew. And so the rainbow effect with the refraction and reflection is happening even with just dewdrops. You don't need all of this cloud and rain kind of stuff going on in the sky necessarily to get the effect. So very beautiful stuff there. Now we will move to one of my favorite things to talk about in weather. And we'll just touch on it quickly because this is a pretty big deal and you could talk about this for a long time. But what I love perhaps most is the idea of the auroras, Aurora Borealis and Aurora Australis. So actually, for the students joining me, if you have Frozen, has anyone seen the movie Frozen? I have a feeling most of the adults watching have also probably seen Frozen if you have kids at home. I'm getting into Frozen 2, by the way, right now. I haven't finished it yet, but it looks pretty promising. But in any case, what we have here are the auroras, and you can actually see them showing up in the movie. If you look at certain points in that movie, you can see the sky kind of shimmering with these beautiful colors. So in this case, what happens, and for my school friends, and my student friends, just to kind of let you know why these are happening, because they are so beautiful, is because it really all starts with the sun. So the sun emits these what we call solar flares and sends out little particles, and they go all the way across space and they reach the outside of the Earth. So they reach our atmosphere and, more importantly in this case, our magnetic field that we have around the Earth. Invisible to us, but we do have a magnetic field covering the outside of the Earth. At the two poles, the magnetic poles, the North Pole and the South Pole, those particles can sometimes become very energized and excited, and they emit light in these gorgeous patterns that you can see with the auroras. So those are, you know, what we would call an aurora, an auroral arc. They have auroral bands and things like that, different shapes of the beautiful colors. And so did you know that the colors, actually you may have seen them in purple shades or green shades, they depend on the energy of the charged particles. So these particles that are making their way from the sun to the outside of the Earth, and the molecules that they interact with in the air. So maybe for a few of you slightly more advanced students who know our air is made up of maybe oxygen, right? And oxygen would produce, interestingly, the green shades. And if you were to have a more purple kind of colored aurora, that would be produced by nitrogen in the atmosphere. So just a couple of cool little tidbits for those of you thinking about that. So I love auroras. These are hard to see though. I always tell students in my different classes that I go to see, I don't know, we're not going to see them in Louisiana, we're too far south. But if you were to go really far north or really far south to the South Pole, that's where you could see these beautiful displays happen. So I had always wanted to see these for a really long time, and I just recently was able to see them a couple times, so that was really cool. Okay, and moving on down our little backward list here. We've made it through a lot of cool stuff. Now we're going to stop with our last two, and this is going to be something that I think is really beautiful, and I'll show you a few of these. They're called crepuscular and anti-crepuscular rays. So the name a little bit strange perhaps, but it is essentially when you get this kind of beautiful effect of the light and shadow coming down in that pretty kind of display. Do you see from the sun? You have light rays, you have these shadows or dark rays, and they kind of mix to create this look. That would be crepuscular rays. And so it really does happen because of the clouds. The sun is shining and kind of getting blocked in certain parts by the clouds. So that would be crepuscular rays. Then there is something that I think is one of the most beautiful things that I've ever seen, maybe even rivaling auroras and things like that. And that would be anti-crepuscular rays. And this is what that looks like. Can you guys see that? I have seen this many times actually in South Louisiana. I'm from Slidell, I live in New Orleans, but I have seen this, especially kind of near the lake or in big wide open spaces. And so this beautiful phenomenon, anti-crepuscular rays, and I have seen it just as strong as this for sure. These happen because there are crepuscular rays, or the sun and cloud kind of effect, going on in one part of the sky, especially at sunset or sunrise. And the light bands from that, the shadows of dark and light, shine all the way overhead, all across the sky to the other part of the sky. So these beautiful colors are happening not where sunset is going on, but in the other part of the sky, anti-solar part of the sky. So sometimes, I tell kids this in my classes too, when I see a beautiful sunset with that kind of effect, with light shades and dark shades and the sun, sometimes I look at it and I take it in and I say, oh, this is beautiful, and then I look around and I look completely backward to the other part of the sky where the sun is not happening and there's no sunset, and I try to see if you can see the anti-crepuscular rays. So I think that those are really, really beautiful. So we've talked about all of these different things. We've started with coronas. We went to halos. We talked about halos with sundogs. Rainbows, of course, very little explanation there, but then also dew bows and fog bows. Oh, some people are saying they have pictures of this. Yes, I'd love to see it. Please send it. I would love to see your photos, of course, of these beautiful atmospheric optic type things. We touched briefly on auroras, and then we talked about the two beautiful displays that you can see here in South Louisiana sometimes with sunrise and sunset. Crepuscular rays and anti-crepuscular rays. Crepuscular where the sun is, anti-crepuscular in the other part of the sky. So this was just a really quick, cool. Someone said sunsets are going to be cooler now. I hope so. I do love sunsets, and as you know, we have just absolutely beautiful sunsets here in South Louisiana. Maybe we could talk about that one time too. Okay, so at the beginning of this first weather lessons, I said we're going to keep this one pretty short and kind of just touch on a few things. What I want to set up for tomorrow, and this is going to be at 1 p.m. tomorrow again, is an experiment. We're going to talk about clouds. And I need for kids, and if you have a parent at home who could maybe help you with this, that might be good. All you need is a water bottle, an empty water bottle, and a match. So again, if you think you need it and aren't old enough, maybe get your parents for sure to help you with that, because we will light a match very briefly and then blow it out. It won't be lit, but just for a second. And we're going to kind of create a way to make clouds. So if you're interested in that, which I love clouds, hopefully you do too, we're going to make a cloud tomorrow in our experiment on Weather Lessons 2 on Friday. So thank you guys so much for tuning in from all your different locations. I am seeing your comments pop up, so it's so much fun to see this, and I'll go back over them in a second and I will talk more on that, or kind of look at where you guys are coming and tuning in from. And then tomorrow we're going to do our cloud experiment. So again, this is the first one. Thank you guys for being with me on this little kind of trial run of a weather lesson. And I hope that more students and parents, if you want to join tomorrow and probably next week, we're going to keep doing this so you can get a little bit of learning in, even though you may be staying at home, just like me with my self-quarantine that I have going on. So that'll do it for this one. Thank you so much for joining me, guys, and I hope you have a good rest of the day. Hope to see you tomorrow at 1 p.m. Take care.